How do stars and planets form and evolve? Stars and planets form from the same material, giant molecular clouds of gas and dust. Stars form through the gravitational collapse of these clouds, leading to nuclear fusion, while planets form in the leftover material around the star, mostly within a flattened disk called a protoplanetary disk. Stellar evolution involves the star's life cycle, which includes nuclear fusion, expansion into a giant or supergiant, and ultimately either a remnant, white dwarf, neutron star, or black hole, or ejection of gas. Stars are born in dense regions of space called giant molecular clouds, which are composed primarily of hydrogen and helium, with trace amounts of other elements. Gravity pulls the gas and dust within the cloud together, causing it to collapse and form a protostar. As the cloud collapses, it starts to spin, and the infalling material forms a flattened disk around the protostar called a protoplanetary disk. The protostar's core heats up and compresses, eventually reaching a temperature and density where nuclear fusion of hydrogen into helium begins, marking the birth of a star. A star that is stably fusing hydrogen in its core is known as a main sequence star, and this is the longest phase of a star's life. The protoplanetary disk is the birthplace of planets, containing the leftover gas and dust from star formation. Dust and small particles within the disk collide and clump together, forming larger bodies called planetesimals. Planetesimals continue to collide and merge, eventually forming larger bodies called planetary embryos, which are roughly as massive as Mars. Planetary embryos continue to grow through accretion, eventually forming planets. Giant planets like Jupiter and Saturn form in the colder outer regions of the disk, where they can capture large amounts of gas. Rocky planets like Earth, Venus, and Mars form closer to the star, where there are fewer gas molecules available. A star spends most of its life on the main sequence, fusing hydrogen into helium in its core. As a star runs out of hydrogen fuel in its core, it expands into a giant or supergiant star. The fate of a star after the giant supergiant phase depends on its mass. Low to medium mass stars can become white dwarfs, while more massive stars can become neutron stars or black holes. Please like and follow, and thanks for watching.